if you recall, we talked about the Earth's temperature. Now, at any given time, the temperature on Earth, it's a balance between the incoming energy from the sun, which we call insolation, and the energy radiating from the surface of the Earth. Now, most of the energy coming from the sun is in the short wavelengths of energy because the sun is so hot, 6,000 degrees Celsius at the surface. But the Earth is much cooler than the sun, about 20 degrees Celsius on average for the surface. And most of the energy being emitted by Earth is in the infrared portion of the electromagnetic spectrum. So it's emitted from Earth, and it is these infrared wavelengths that are absorbed by gases in the atmosphere that we call greenhouse gases, namely carbon dioxide, water vapor, methane, these other gases. Then that energy that those gases absorb is re-radiated, and some of it comes back down and warms the surface of the Earth. This is what we call the greenhouse effect. And the greenhouse effect it's natural, it's normal. It maintains the temperature of the Earth about 40 degrees Celsius higher than it would be without these gases in the atmosphere. And that's a good thing, because without it, the Earth would be about minus 15 degrees Celsius, and all water would be frozen, and we wouldn't be able to support life. So the greenhouse effect is natural. And we'll talk later on in the semester about the impacts of man and the enhanced greenhouse effect, how the number of gases in the atmosphere has been changing. So the energy from the sun, this shortwave radiation, about half of it is absorbed by the surface of the Earth. The other half of it is reflected or absorbed in the atmosphere. And that energy that's absorbed by Earth then warms up the surface of the Earth, and the Earth releases infrared wavelengths of energy, this terrestrial radiation over here, some of it which is sent back down toward Earth and warms Earth. So we end up with the solar constant. This is the amount of incoming solar radiation reaching the top of the atmosphere. Varies a little bit. You'll see different estimates, but it's right around 1,366 watts per square meter, or 432 BTUs per square foot, and that's per hour. So the amount of incoming solar radiation, or insolation, received at the surface of the Earth, of course, it's going to vary, right? Different latitudes, different times of day, different seasons, and clouds. So it could be 0 at night, when it is winter in the Arctic Circle, and it can be fairly high when the sun is high in the sky in the middle of summer without any clouds. Okay, so the Earth is tilted on its axis 23.5 degrees. And this tilt of the Earth is very important. This is what gives us our seasons, right? The North Pole is tilted toward the sun during the summer in the Northern Hemisphere. And that gives us more hours of daylight and the sun higher in the sky, which gives us more energy from the sun. So the sun is highest in the sky in the Northern Hemisphere where we live on June 22nd. And this is when we're going to get the greatest amount of solar radiation hitting a horizontal surface, so a flat surface on the ground. And so this is the Northern Hemisphere. This is the 23.5 degree tilt of the Earth from straight up and down. And this is summer in the Northern Hemisphere, when the Earth is tilted toward the sun. We get more daylight hours and more intense solar radiation. In the winter, the opposite is happening, where the Northern Hemisphere is tilted away from the sun, excuse me, the northern hemisphere